Spacetime's texture could be torn faster than we can perceive, and this thought has left me feeling panicked. The night sky is changing in ways that may make it difficult to recognize in just a few years or even sooner. Astronomers around the globe have sounded the alarm, with Neil deGrasse Tyson and other experts recently revealing a shocking truth. Polaris, our North Star, is on the brink of exploding, and its story is more alarming than we could have imagined. Polaris's special position as the North Star stems from its location near the celestial North Pole, making it appear almost stationary in the night sky. It's been a constant guide for navigators, astronomers, and stargazers alike. But that could soon change. A new study, released by the prestigious Royal Astronomical Society in September 2023, has cast doubt on the fate of this iconic star, suggesting it could soon explode and disappear from the night sky forever. Before delving into what this means, let's take a closer look at Polaris itself. Also known as the Pole Star, Polaris is part of the Ursa Minor constellation, the Little Dipper, and sits nearly directly above Earth's North Pole. This unique alignment makes it seem stationary to observers in the Northern Hemisphere. Polaris is a yellow-white supergiant, much larger and brighter than our Sun, though it's located far away at a distance of 323 light-years. Interestingly, Polaris is not a single star, but a complex system of 3 stars: Polaris AA, Polaris AB, and Polaris B. The first two, Polaris AA and Polaris AB, appear as one star to the naked eye, but they orbit each other, creating a gravitational interaction that influences their brightness and behavior. These stars, along with Polaris B, form a dynamic system that can exhibit changes in brightness and stability. The thing is, we wouldn't know if Polaris had already exploded, because light from such an event would take over 300 years to reach us. That means the explosion could have already happened, but we simply haven't seen it yet. Polaris has been crucial throughout history, providing sailors and travelers with a reliable navigational point, and in many cultures, it symbolizes steadfastness, constancy, and safety. It has acted as a guide for centuries, marking a stable point in the sky, and its disappearance would be profound. Lately, however, astronomers have noticed something unsettling. Polaris's behavior is becoming increasingly erratic. Its usual pattern of pulsations, where the star dims and brightens at regular intervals, has been disrupted. The pulsations are becoming more irregular, and scientists are unsure why this is happening. This behavior is reminiscent of the changes seen in Betelgeuse, another star that exhibited similar irregularities before it went through drastic changes. Like Betelgeuse, Polaris's changing pulse could signal the end of its life. Polaris's irregularity in brightness, particularly the increase in the length of its beats, suggests it may be nearing the end of its life. This change could be linked to the interactions between the stars in its system. The pulsation cycle, which previously remained stable, is now showing signs of lengthening. While a 4-minute increase might not seem significant at first glance, it indicates a larger trend in the star's behavior. Some scientists believe that Polaris might be nearing the end of its life, as the changes in its pulsations mirror those seen in stars like Betelgeuse, which are nearing their supernova stage. These fluctuations are typical in stars that are entering their final stages of life, and experts are watching Polaris closely. When stars like Polaris reach the red giant phase, their energy output rapidly increases, eventually culminating in a violent explosion, known as a supernova, where the outer layers are ejected, leaving behind a white dwarf. Despite these concerning signs, some researchers remain skeptical, and there has been no official confirmation of imminent danger. However, the similarities between Polaris and Betelgeuse's behavior have raised alarm bells in the astronomical community. We can only wait and watch as this potentially dangerous phase unfolds. If Polaris does explode, it will be a cataclysmic event, changing the night sky forever and altering our understanding of the cosmos. As the North Star's time comes to a close, the sky will never be the same again, and humanity's methods of navigating and measuring the stars could undergo a drastic transformation. The question now is not just when Polaris will explode, but what the consequences will be for the Earth and the rest of the universe as we know it. After a blast, The remaining thick and conservative body of Polaris has led experts to believe that the star may have entered the helium loss phase, a characteristic behavior seen in stars nearing the end of their life cycles. When a star depletes its helium supply, it undergoes erratic pulsations that alter its brightness. This loss of helium triggers a chain of events that can cause the star's light to fluctuate in unexpected ways. These unusual patterns align with behaviors observed in stars nearing the end of their lifetimes, but definitive proof that Polaris is indeed going through these final stages is still lacking. Astronomers continue to study these anomalies to understand their true significance. Should Polaris eventually go supernova, it would be an extraordinary sight in the sky. The star could suddenly become so bright that it would rival the moon, shining as one of the brightest objects in the night sky for days, weeks, or even months. The star's appearance might drastically change, possibly becoming a brilliant point of light or a moving object, and it could even emit vibrant colors before fading away. Fortunately, Earth would likely remain safe. Due to the size and mass of Polaris, a supernova would not pose a direct threat to our planet, even though it could be incredibly bright and visible to the naked eye, outshining nearby stars. While a Polaris supernova would be fascinating to observe, it would have a less dramatic effect on Earth's atmosphere compared to a supernova occurring closer to our planet. The event would still captivate astronomers and researchers worldwide, who would be eager to study the phenomenon. However, the immediate environmental impact would likely be less significant than that of a nearby cosmic explosion. A supernova generally marks the death of a massive star. However, this is unlikely for Polaris. In the case of very massive stars, those with several times the mass of our Sun, their core collapses once they exhaust their nuclear fuel, causing a violent explosion that propels their outer layers into space. This explosive event, known as a Type II supernova, results from the collapse of the star's core, which triggers a shock wave and an intense release of light and energy visible from vast distances. On the other hand, Type I supernovae occur when two stars in a binary system interact, with one of the stars being a white dwarf. If the white dwarf accumulates enough material from its companion star, it can undergo a catastrophic nuclear fusion event, leading to a powerful explosion. These Type I supernovae are crucial in measuring cosmic distances because their consistent brightness allows astronomers to use them as standard candles to estimate the age of the universe and the rate at which it is expanding. Following a supernova, the core of the star may collapse into a neutron star or a black hole. Neutron stars are incredibly dense, with a mass 1.4 to 2 times that of the Sun compressed into a space no larger than a city. They are composed primarily of neutrons, the tiny particles found in the nuclei of atoms. Black holes, however, are even more extreme, possessing such intense gravity that not even light can escape their pull, rendering them invisible in the vast expanse of space. Despite Polaris displaying strange behavior, it is not expected to end its life in a supernova. The observed irregular pulsations and fluctuations in its brightness suggest it is nearing the end of its life cycle, characterized by a lack of helium and changes in its luminosity. Astronomers continue to monitor Polaris closely to better understand these shifts and uncover what they may mean for the star's future. While speculating about the possible outcomes of its evolution, whether it might become a white dwarf or undergo other transformations, is intriguing, the exact fate of Polaris remains uncertain. In conclusion, Polaris has played a significant role in human navigation, culture, and scientific endeavors for centuries. As it shows signs of change, researchers are eager to unlock its mysteries and deepen our understanding of stellar evolution and the broader universe.